IVM.
Welcome to All Things Policy, a daily podcast by the Takshashila Institution. We are a bunch of policy nerds based in Bengaluru, and we like bringing fresh perspectives to Indian affairs and Indian perspectives to global affairs. So grab a cup of coffee, sit back, and join us for today's chat.
Hello and welcome to this episode of All Things Policy. Today my colleague Anirudh and I are going to be discussing evolution. As Theodosius Dobzhansky, apologies for any name mispronunciations, famously wrote, "Nothing in biology makes sense except in the light of evolution." Evolution is all around us. We ourselves are a product of evolution, and we are currently being harassed by a little small virus, which is also a product of evolution. So today we thought it would be nice to have a discussion on principles of evolution, how creatures actually evolve, and not by studying evolution on Earth, but rather in a hypothetical moon that Anirudh has just discovered. Anirudh, you want to tell us a bit more about Serina?
Hey, Doc. So, Serina is this interesting speculative evolution project that I came across on Reddit last week. And since then, I have been absolutely obsessed with it. The basic concept of Serina is that some highly advanced life forms, which are heavily hinted to be humans, have found this little moon that is in orbit around a gas giant. And they've terraformed this moon to make it basically a laboratory for life. And what they have done is basically made liquid oceans, with 5 massive continents. The entire moon is about 2/3 the size of Earth. They have seeded it with everything it's going to need to have a life for a few 100 million years. So it has these very verdant meadows covered in grasses, gentle rolling hills, very generally warm, almost tropical conditions. And they also put in a whole bunch of different invertebrates, such as earthworms, ants, various arthropods, to just digest dead organic matter. They've also seeded the oceans with guppies, who are these tiny, cute little fish in a moderate number. But the most interesting thing that they add to Serina is the Atlantic canary. Now, this is probably, I think, a tribute to Charles Darwin. As we all know, Charles Darwin very famously figured out the principles of evolution by studying the beaks of finches on the Galapagos Islands. So what the creator of this project, a chap called Dylan Bajda, who, again, apologies if I'm mispronouncing your name, Dylan, if you're listening to this, but he is an absolute mad genius. And then what he does is that by introducing this little canary, this species of finch, onto this endless world of verdant meadows with gravity about 2/3 that of Earth, so it's perfect really for flight, what he does is that he indulges in this extraordinary thought experiment that has stretched over the last few years, trying to sketch out how life evolves over hundreds of millions of years on the planet of Serina. And reading it has really filled me with appreciation for the extraordinary history that life has had on Earth as well, because unlike on Serina, where the only tetrapod or 4-limbed creature to exist on land are canaries, we have had many, many different lineages of tetrapods on Earth. And rather than just existing for 400 million years, life has been around on Earth for nearly 4 billion years. That's an awful lot of evolution. That's an awful lot of radiation and speciation and ecological diversity and complexity that Earth has built up over all this time. And it's really filled me with an appreciation, not just for evolution, but also for the amazing history of life on Earth within which we find ourselves.
Yeah, and the fact that life on Earth predates humans. And I think that balance before humans came in is probably what is reflected in this project as well.
Yeah, exactly. And the sheer scale of it is what is most impressive to me, right? I mean, frankly, humans, with everything that we've done and all the impacts we've had on ecosystems over the last few millennia, we're a mere blip in just the sheer vastness of the history of life. I have this little poster up in front of my desk, which I tend to look at every now and then, called the Great Tree of Life, which shows you this this massive radiation across many, many millions of years. And humans are just one tiny branch of this great tree, which has had so many other, much, much more successful branches, such as, the overall history of mammalian life, the overall history of dinosaur life, which lasted for much, much longer than we have. It's really awe-inspiring to think of everything, all the interactions, all the stories of these organisms that have filled the continents and filled the oceans, and just how tiny they make our species feel in comparison. It's really amazing. Life is awesome.
If only rocks and plants could talk.
If only.
So let's go back to Serina, and let's go back to what happens when life first begins there.
So life on Serina starts out in a way that I didn't fully expect, but then I'm not exactly a biologist. So I was pleasantly surprised by the fact that it's not really the canaries who really emerged to become the most important species on Serina, but within about 10,000 years or so, it's really insects that really take over this planet. Specifically, ants. Ants evolve into fairly massive sizes. I say massive, but I mean they're ants, so like about as big as maybe a finger or something. And they start to develop these large crushing mandibles to process enormous amounts of plant matter and also to feed on other species. So very rapidly you see these colonies of trillions, if not quadrillions of ants that spread across the many continents of Serina at a scale that has never been seen on Earth. Simultaneously, in the oceans, you see these small species of fish gathering in these gigantic shoals of tens of billions of individuals to feed on the algae of the planet. And it's not really a very balanced ecosystem. So very obviously what is happening in the first few millennia of life on Serina is that the species that are best suited to take advantage of the environment basically explode in the sheer size of their population. Though, of course, you also see some species kind of developing unique adaptations to kind of fill in specific ecological niches. So coming back to the canaries that this entire project began with, they soon begin to develop into slightly more specialized forms. So you see, for example, canaries that are specialized at eating insects. So they develop these long, narrow beaks. You see other canaries that are specialized at eating seeds. So they have much thicker beaks. And of course, you also have herbivorous canaries that are these large bumbling individuals that basically walk around the ground and like feed on grass and also nest on the ground. Unfortunately, as you can imagine, these ground dwelling canaries don't do very well with these gigantic ant colonies. Very large numbers of them are eaten alive. Their eggs and their chicks, which are on their nests, are also eaten. And so the species is driven very rapidly to extinction, which is not what you would expect on a moon that was designed specifically to bear life. But that is actually how life really works. It's about competition, and inefficient forms that aren't well suited for competing with other forms that are out there eventually die out. And as sad as I feel for those cute, fluffy little round canaries, such is the nature of life. And let me promise our listeners that there are far more harrowing stories that lie ahead in the story of life on Serina.
Yeah, I think morality is a luxury that humans have, but nature by itself can be pretty brutal. I mean, this exact story of ground-dwelling birds being wiped out by another species basically occurred on New Zealand, right? Because New Zealand for a long time did not have a lot of predators, which meant that their birds would nest on ground, kiwi being an example. And when colonists started moving to New Zealand, they brought pets with them. And the poor birds had absolutely no way to defend against four-legged running creatures coming at them. And afterwards, strong conservation programs had to be established. Speaking of ants eating nestlings, I mean, we have this horrible experience. So I come from a coastal village. Beach is a conservation beach for the olive ridley turtles, and the olive ridley turtles would usually come to nest in starting November, so November to Jan, and then we would have the eggs hatch after 52 days. For some reason, and it's been attributed currently to climate change and warmer seas, the turtles have been coming later, so more closer to Jan or even Feb, and consequently the eggs hatch even later. When summer comes in and if the eggs still haven't been hatched, we see a lot of ant predation. Because that's the time the ants also come out of their dwellings. And as a consequence of civilization, so there's more human settlements around the beach, and the fact that there has been this change of time for when the eggs are actually around. We have seen this completely changed behavior from ants who now come and prey on the eggs, and it's a horrible sight to see when you actually dig out the eggs to see why the hatchlings haven't come out yet, and to find this swarming ant colony. It's just the worst sight in the world.
That is sad, but I don't think the ants would agree with us, unfortunately. This actually reminds me of
this. And again, that's completely natural. It's brutal, but that's the way nature works.
Absolutely. This reminds me of this beautiful animated short film I saw called Sharp Teeth. It's basically an animation that's set at some point in the era of dinosaurs, and it's about this ceratopsian and her baby, and the baby's really cute, and it's just like bumbling around doing its thing, and then it's captured by this massive predator and killed. And I won't spoil the ending, but as brutal as it is, this video gave me a perspective that there was a little less hurt by the brutality of the natural world. The nature is the way nature is.
Yeah, and nature has balances for that precise reason, right? So, for example, if you are the fact that the turtle eggs are left that way, the mother goes away, there's no one to take care of them, also means that she will lay a lot of them, unlike a species like humans, where our young are also completely fragile, but then the parents hang around to take care of them. Right? Yeah. It's actually one of the reasons why we think why civilization could even happen.
Exactly.
Was because we felt this need to be in a group.
That's a very interesting point. And so you actually talked about two different reproductive strategies, which we're going to see come up in Serina later. But before we get to that point, the idea of like nature trying to bring in this balance is, I think, very interesting because even though for about 1 million years or so, insects have their way with Serina. They're just like partying and they're expanding. Simultaneously, you're starting to see these grasses, especially bamboo species that were introduced to Serina, starting to spread from pole to pole because it's a fairly warm and wet climate. But within a matter of time, you gradually start to see these grasses, specifically bamboos, which were so vulnerable to these gigantic swarms of ants, starting to evolve ways to compete and to survive against these hordes. Specifically, a new kind of species of ants evolves that lives in symbiosis with these bamboos. So they basically live in the hollow stalks of the bamboo, and they harvest the bamboo's competitor species to build up these colonies of fungi that they feed on. And they also defend the bamboo species that they are home to against other invading species of ants. So these gigantic empire ants slowly start to fade out because of competition from other species of ants. And also, even though the cute bumbling herbivorous canary species were driven almost to extinction, the avian ones that live on higher stalks of grass and nest in higher stalks of grass manage to survive and gradually become more and more efficient at eating ants. So gradually the population of ants begins to decrease across the world. In the oceans, however, it's kind of a different story because life can only really exist in shallow seas. It can only exist where algae are close to the surface. Deep in the ocean, you have anoxic conditions where you have almost no oxygen. So species simply cannot live there. So essentially what you see is that in these non-oxygenated conditions, you see these massive colony of anaerobic bacteria and algae that develop, and they release these huge amounts of like toxins into the waters, which actually kill out large amounts of marine species. So you're talking about numbers in the tens of billions. So you'll have these extraordinary blooms where these algae form and life feeds on them. And then sooner or later, like a flow of like toxins comes in from deeper in the ocean and wipes out entire colonies of fish. So the world is still not entirely in balance. But again, as the world continues to evolve, you start to see some species that specialize in actually moving down deep into the ocean floor, even though there isn't a lot of oxygen. And because there are massive amounts of biomatter that just are lying there decaying, they start to specialize on eating that. And as they're doing that, a flow is established deep in the oceans that moves nutrients from the top of the oceans to the bottom, and thus enables life to move into deeper and deeper levels of the ocean, and thus slowly brings the oceans into balance by stopping these horrible anaerobic algal blooms. I mean, it is such an amazing story to think about, the sheer scale of like these entire oceans doing these things. But also on land, interesting things start to happen finally as canary species start to grow larger and larger. And many of them start to lose the ability to fly and start to just run around on these endless meadows of Serina. And we start to see some pretty interesting species start to evolve. One group of them, for example, are called axebills. They flock in massive herds of like tens of thousands, and they basically use their thick beaks to shear coarse grasses and kind of digest them. And we also see a very important group of species called the art geese. The art geese basically start to develop these longer digestive tracts to process very poor quality plant matter. They're not very large creatures. I mean, they're probably like come up to your knee or something, but they're fairly successful. They grow up. They grow in these small family units where you basically have an art goose male and like 5 or 6 females, and he assists in rearing the young. And these art geese will eventually evolve to become one of the most successful species on Serina. I would really suggest that you guys check out the website of Serina, because there's also beautiful little artwork which shows you how all these species look, and it's really, really something to look at. These are, of course, the land-dwelling species. Since canaries are originally flight species that fly, you also see these gigantic flocks of millions, if not billions, of individuals. So just imagine these huge flocks of colorful birds, unlike anything you've seen on Earth, flying across these gigantic, endless meadows with gentle rolling hills, covered in a species of bamboo that have these colonies of ants on them. And also keep in mind that since all of these birds are descended from canaries, which are songbirds, all of them retain the ability to sing. So every species of art goose, every species of axebill, every species that is on Serina has the ability to sing in various different ways. So if you can actually imagine yourself there at night on Serina, when these endless meadows are bathed in the light of the gas giant around which Serina orbits, you will hear songs of so many thousands of different species of birds. It's a pretty awe-imagining concept to think about.
Anirudh, you said something, and I wanted to ask a question on that. You said that some of the species are successful. What is your definition of successful, or rather dominant, or any of those? What's a successful species?
Well, I think one way of measuring it is just in terms of the sheer number of individuals that are around. Mm-hmm. Another way to measure it is perhaps in terms of how much they shape the environment around them. And another way perhaps is the sheer amount of biomass that they make up within an ecosystem.
Yeah, because by some of those definitions, humans are probably not the dominant species on Earth.
Exactly.
And I'm just wondering whether our understanding of the world and dominant species is also shaped by our need to be number one.
Of course it is. I mean, we are the ones who have written the natural history of Earth, and it only makes sense that we would seek to situate ourselves at the center of it. But strictly speaking, by some of these definitions, perhaps in terms of environmental impact, yes, we are one of Earth's dominant species. But in terms of the sheer amount of biomass, we certainly are not. If you were to gather together all humans on Earth right now, we would probably make up like a cone that's a few kilometers tall and like a couple of kilometers wide. There aren't really that many of us. In terms of biomass, fungi definitely make up far more biomass than we ever could. And in terms of sheer numbers, of course, bacteria and viruses like outnumber us by orders of magnitude.
Yeah, I mean, even in our own body, there are more of them than there are human cells. So,
yeah.
Yeah, cool. So, let's get back to Serina.
So continuing with the history of Serena, so the first 10 millions or so, it's a fairly tropical, fairly warm planet. But things begin to change in the next era of its history, which is called the Temple Scenic Era, from about 11 to 50 million years. So at this time, the planet gradually starts to cool. And here's the thing that I find most interesting is that he also takes into account of this history the movement of the continents, and that is just nuts. So basically what happens in the tempo scene is that you broadly have two groups of continents that emerge. Within the center are large islands, which we will get to hopefully in a little while. So what you see on the eastern continent, which is somewhat colder, is that the descendants of geese begin to develop some really, really interesting evolutionary adaptations. So geese, as I mentioned, are basically very small-ish kind of birds that used to eat coarse grasses. But by this time, a few million years from the time when they first appeared, they have really specialized to eat these coarse grasses by developing a much longer system of intestines. So in order to accommodate these intestines, their body plans have also changed. So they begin to develop larger and longer backsides, and they start to develop larger and longer tails, and more developed kind of musculature systems for eggs and so on. So because these start out as relatively small and vulnerable birds, the females developed the ability to basically control when eggs come out of the oviduct, and gradually they start to develop the ability to retain the egg within the oviduct for most of its incubation period. And it gets to the point where as these creatures are growing, are speciating, you see larger and larger varieties of geese evolving. You also see them moving more and more towards live birth, to the point where an egg will pop out and it's almost fully developed, and it'll only need to be incubated for a couple of hours before the baby comes out, and it's almost fully developed, so the baby is able to run along with the mother and is therefore almost totally safe from predators. And also the fact that the egg is maintained within the mother's body instead of having to be put on a cold piece of ground means that the geese are also able to spread into much colder environments. So you can imagine these great, almost 12-foot tall bird-like creatures that have lost many of their feathers and are only covered in a very fine kind of down, that gather in these groups of 10 to 12 individuals and kind of raise their own young. So very interesting to think of the idea of live birth evolving within a bird species, right? It's not something that we see in birds on Earth today, but the way that it's presented, given the natural history of Serena, where you have a cooling climate and you have all these evolutionary pressures, just makes a lot of sense.
Yeah, I was just wondering about how they can fly with the.
They don't fly anymore, so they've become totally
that's why they can probably do it.
And they also,
I don't think we have a lot of flightless birds that have survived.
Exactly, but here's the thing.
That kind of mechanism.
On Earth, not a lot of flightless birds have evolved that are very fast. So you have ostriches, for example. Yeah. But if you look at emus, or if you look at moa birds or the extinct elephant bird of Madagascar, all of these were massive species that evolved because there were no predators around.
Yeah.
But on Serena, you do have predators. So axebills have evolved into more sophisticated predators that are able to run behind their prey and eat the young who aren't fast enough and so on. So that means that geese evolved to become faster and faster. So once again, really recommend you check out the Serena website to see illustrations of these creatures, because they just look so weird. So imagine an ostrich that's totally covered in feathers, but also has a very long extended tail and is capable of running very fast. So it's really quite interesting. And of course, these are the largest species of canaries that are around. You also have much smaller canaries. So for example, there's one interesting species that Dylan talks about that has basically developed a kind of symbiosis with the cricket. So basically the cricket creates these burrows near the surface, and the birds hide in them during the daytime. And during the night, when the cricket comes out to forage, the bird helps out the cricket by keeping an eye out for predators and calling out, so the cricket knows when to run back inside. These are things that we do see on Earth, where you have these kind of close interactions between species that basically agree to live and let live in the interest of competing against predators.
Cool. So I think there's a lot of exciting things that's happening on this moon, and we are only a few million years into it, and it has 300 million years. So can you tell us a bit more about what follows?
Yeah, so I'm going to try and accelerate the pace, and let's specifically look at what happens to these crazy Geese species, and try to broadly situate them within the context of the history of Serena. So this is the Temple Scenic Era, so it's broadly a very temperate kind of climate. The next era of Serena, you start to see the planet begin to cool, and the continents begin to separate even further. So what happens over this time is that you start to have other species of birds that really become specialized carnivores. So even though they evolve from herbivorous animals, they become very, very effective carnivores. You start to see these really gigantic species of birds evolving on the other side of the planet that are specialized to kind of browse the foliage of bamboo trees. And you see much smaller species of finches that specialize in keeping out insects, that keep out ants that are symbiotic with the bamboo species that these massive birds eat. And of course, you also have interesting species that kind of disguise themselves so they look like the symbiotic finches, but actually feed on the blood of these gigantic moving birds. Gradually, you see the evolution of some species of birds that have some kind of teeth. So basically, they have these rough surfaces on their tongues and these rough surfaces on their upper beaks, and they can chew plant matter by rubbing their tongues against their teeth. They gradually evolve cheeks in order to make sure that more plant matter can remain in their mouths. And then gradually some of them start to become much smaller. They start to climb onto trees. They start to develop little talons that allow them to swing from a branch to branch, almost like monkeys. And then gradually, as the planet begins to become warmer, these monkey-like individuals that used to kind of walk around on the talons on their wings instead of on their back feet gradually begin to lose all the feathers. They start to lose their wings, and these knuckles essentially become like feet. So what you start to see are essentially four-legged birds that expand across Serena, and all kinds of like really interesting stuff begins to happen. You start to see convergent evolution, where if you think of a ecological niche that you see on Earth, you will see a species of bird that has evolved to do something very, very similar on Serena. So this example I just gave you is what Dylan calls a sericel. So they basically fulfill a function very, very similar to what gazelles do on Earth. And I also talked earlier about these monkey-like creatures on Serena. The most interesting dynamic that I see on Serena, though, is on the islands that exist between these continents, where you start to see the evolution of these specialized kind of like burrowing birds that develop very sensitive noses, and that because of a variety of environmental pressures eventually start to grow larger and larger, and their sensitive noses actually become a trunk sort of thing, and Dylan calls them elephantches. Though of course elephantches eventually become extinct because the island becomes a part of this large landmass supercontinent, as it were, that unites all the continents of Serena together. So they become extinct because of competition, because ants come in and basically eat all the trees that they used to eat. Gradually, through the Pangea, you start to see the evolution of very rudimentary forms of intelligence. And then in the final era of the history of life on Serena, which is called the Ultimocene, you start to see many, many different species of birds and even fish, and start to develop complex intelligence. So they are actually sentient little creatures. And unlike our planet, where you just had one really intelligent group of species, the genus Homo, and among which we are the most intelligent species, eventually driving all the others to extinction, here on Serena, you start to see many, many different forms of intelligence in many different forms of species. So one example of these species is a small little bird that does agriculture by cultivating snails and also various small fungi. And these birds have also developed small fleshy thumbs on their wings, which they use to kind of manipulate snails and do things with them. So imagine if you are one of these sentient birds and you're trying to develop culture, what would you think of, for example, a sentient bat that also has culture and that kind of you compete with in various different areas? How would your culture develop with the awareness of many other different sentient species that are not related to you at all? So it's a really amazing idea And the world of Serina is still evolving. It's still got a few million years to go before life comes to a close. But there's so many fascinating, zany things that happen over the course of life on this planet. And I really, really cannot recommend enough to all of you to just go and check it out and just think a little about the amazing things that must have happened and are continuing to happen in the history of life on Earth.
Yeah. I mean, the idea about intelligence and the agriculture, right?
Yeah.
So, for example, ants are known to nurture gardens of fungi. So, and then that basically creates food supply. So they form these. They actually look like manicured gardens within the. Within.
It's not
they're known as the ant garden. I think
we're nowhere near as unique
gardens.
in a lot of the things that we do as we like to think that we are.
We aren't. I think the main difference between human beings as a species and any other intelligent species is the fact that we have learned how to manipulate our environment at a scale that others can't. And I think the entire crux of evolution, it's the idea that it's a slow process that helps you adapt to the environment. And we have gone to this level where we are now manipulating our environment as per our own wish. And there are times where there might not be a check and balance on the activities that we do or the impact it has on other species. Because unfortunately, the only weapon the other species have is evolution, which is, again, a very slow process. Which I thought was very interesting about Serina is the fact that an intelligent species, a technology advanced species created this and decided not to step on it. So I'm saying that they're not going to be humans. Because if we created this world, we would definitely be living on it.
Yeah, unfortunately, we probably would. And it probably would not have been as balanced, and we definitely would not have seen life evolve in all these fascinating and creative ways if humans had been around on Serina.
Yeah. We are very disparaging of our own species. But I think there are broader lessons about evolution, and I think human beings' role in our world that we need to understand by looking at projects such as this. And when it comes to future policies, particularly on climate change, I think we really, really need to make some good investments, take some harsh decisions, and make sure that our world has some sort of balance restored to it.
Yep, and we can only hope that life will continue to have as rich and diverse and creative a history on Earth in the future as it has had on Earth in the past.
With that, I think we invite you all to have a look at Serina's website and write to us with your comments and lessons you think that you can take out from that project. Thank you very much, Anirudh, and thank you all for listening.
Thank you. Check out the link in the description. And as Doc said, thank you all for listening to the amazing story of life on Serina.
If you liked our show, don't forget to check out other interesting podcasts on the IVM network. You can tune into them on the IVM Podcast app, ivmpodcast.com, or wherever you listen to your podcasts. You can also follow IVM on social media. The handle is @IVM Podcasts on Twitter, Facebook, and Instagram. And hey, if you'd like to dive into Takshashila's research on technology, strategy, and economic affairs, check us out at our Twitter handle @TakshashilaINST or our website takshashila.org.in.
I hope you enjoyed that show. If you aren't following us on social media, please do. We're IVM Podcasts on Twitter, Facebook, and Instagram. We'd like to thank our sponsors very quickly this week, thewholetruthfoods.com, Storytel, and Seat. We really do appreciate your support. And we had a great week on the network this week, so tune in for some sweetness with our hosts Sadaf and Archit as they hone their sweet tooth and talk about candies. The famous, the healthy, the traditional, and international. Check out Naan Curry, you'll enjoy it. On last week's episode of The Note, Maruk and I spoke to TV presenter and columnist Veer Sanghvi, who analyzed the 2 years of the second term of the Modi government. As China and India signed the disengagement agreement along the LAC, Lieutenant General Dr. Prakash Menon and Manoj Kewalramani joined Suyash Desai to discuss the process and the consequences it will have on the nation and in world politics. Dr. Anton Harder joins Hamsini Hariharan on States of Anarchy to discuss India's right to a seat at the United States Security Council. Ashton Doctor talks about duty, how individually it binds us and how as a society it is liberating. Check out the Habit Coach with Ashton every day. Great show and great fun to listen to that. On Football Show to All the Boys to talk about their loves and sorrows for teams and their current ranks in the world of football. And also do remember to check out Cyrus Says. We had a great week last week. We had Amol Mazumdar, the ex-cricketer. We had Rocky and Mayur. And we did the Valentine special with Aisha and Kunal. Great fun. Do check it out. I'm sure you will enjoy that. And with that, I hope to see you again next week.
मास्क के पीछे अक्सर आपकी मुस्कुराहट छिप जाती है, पर कोई बात नहीं, क्योंकि आपकी आंखें स्माइल करती हैं, दिल खुल के हंसता है। और जब आप आम भारतीयों के किसी खास काम के बारे में सुनते हो, तो सारा देश मुस्कुराता है, एक गर्व भरी प्यारी स्माइल। आप स्माइल इंडिया सुन सकते हो शिफा माइत्रा के साथ हर सोमवार और बुधवार IVM पॉडकास्ट की वेबसाइट, ऐप या जहां भी आप अपने पॉडकास्ट सुनते हो। दिन के 5 मिनट अपनी स्माइल के नाम।